Hey guys, what's up? So in this video we're going to build a tiny trainer by 533, which was kitted and pulled into this nice box by FPVCrate. So basically every part that you need to build this drone is in this box, and if you take close attention and you follow all this video, you're gonna get some details and some steps that you need to do in order to complete successfully a build. This one is a 3S 3-inch drone designed after the Drone Racing League Racer 4, so it's pretty fun. Yeah, let's get on it. Okay, so first we're going to unbox this kit. Let's cut this seal sticker. First thing that we come up with is the bubble wrap. Then we get our set of motors, which are 1404 4533 kV. The motors come with 3 different screw backs. One is going to be to fasten the motors to the frame, and the other 2 bags are going to be to fasten the props to the motors. Now we have 3 sets of props that are the heads-up FPV Tiny Trainer props by HQ, and these are 3 by 1.5 by 3 with 1.9mm shaft, and all of them are smoke gray. Okay, now we have a TBS Unify Pro 32 Nano VTX, which is the VTX we're going to use for this build. This one is made by TBS and can output up until 500 milliwatts of power. It's super small, it's a nano VTX, so fits perfectly into the tiny trainer, and comes with a set of wires, some heat shrink, and the U.FL antenna, which we are not gonna use. For the antenna we have the Lumenier micro AXII, which is a super small antenna, U.FL connector, and this one is a Shorty version. So it's a pretty small antenna that fits perfectly into our canopy for the tiny trainer. So for the main electronics, we get a BetaFPV Toothpick F4. This one is the V3 version and can hold up to 4S. This one is a 20 amp BL-LES all-in-one board. So pretty much it comes with some screws, some nuts, some rubber grommets, and some connectors for motor connections that we're not going to use because we're going to solder directly into the board. For the camera, we're going to use the Caddx Kangaroo Nano. So basically this is a nano camera that can do 1000 TVL, has 1.8mm lens, and it's switchable between 16:9 and 4:3 aspect ratio. Okay, and now my favorite, which is the tiny trainer frame. It comes with a carbon plate, some standoffs and screws to mount the frame, zip ties, and a full set of 3D print stuff. So for 3D print we have the bottom battery tray, which comes like this, and we are going to fold it. We have the camera canopy, which is as well a 3D print mount. We have a top fin, which is going to serve us for thermal purposes. We have BTX and antenna mount tray, which is also 3D printed. And we have a canopy, which is injected molded and comes in smoke gray as well. So to start the build, I will begin with the main plate. So let's open it. So this is the carbon plate that you get. And you get also this zip ties and all the hardware. Let's get it open as well. For this step, we're going to fasten the motors to the frame. As you open it, you should receive some bags of screws. These ones, which are the shorter ones, are the ones we're going to use to fasten the motors. These C-clips are just spares. And these bags of the screws are the ones that are supposed to go with the props to fasten to the motors, but we're not going to use this as well. So we're just going to take the motors. These are pretty good looking motors in my opinion. These are teal and black, and these are the heads-up 533 motors. These are Spec motors designed by 533. So let's get the 4 motors out of this foam. And with a 1.5mm hex drive, we're going to fasten all the screws and all the motors to the frame. A little trick I do is just to fasten one screw, not all the way in, so it can move around like this, and I can align all the motor holes to the bottom plate. So I put first in X pattern like so, and then go ahead and put all the screws for this motor. Okay, here we go. We have one motor mounted right now. What we're going to do is to repeat this motor mounting. So 4 screws, 1 motor to this bottom plate. Okay, so now we have all the motors. What we want to do right now is to flip it, because we're going to put the battery tab. This is really important to do at this point, because as you bend this battery tray, you're going to see these tabs. And these tabs are essential to keep our build going. These tabs are going to go to this part of the frame, to the outer holes of the flight controller. We're going to grab these long screws, and we're going to grab these nylon nuts. So both of these are going to go in this step right now. We're going to grab the same 1.5mm hex drive that we grabbed before. We're going to use one screw, bend this tray, and pull this screw through the TPU as you see it here. And then we're going to pull it through the carbon fiber as it is bent, and then secure it with one nylon nut, as you see over here. We're going to secure one nylon nut through the TPU and the screws, like so. So let's get it all the way through. As I told you before, don't tighten it too much. First, because this is TPU and nylon, so those are plastic parts. We don't want to strip those. And second, because we are going to need to wobble this around in order to get it done. To get this bent perfectly, we need to put the other screw. Okay, so the tray is now secured. Let's get on to the next step. What we're going to do right now is that we also have these holes on the bottom, and we also have those holes on the bottom of the frame. So we're going to take the short screws that comes with the frame, and we're going to put them into the TPU on the carbon frame, as well with some standoffs for the rear. So we're going to take 2 standoffs and 2 short screws for this step. Put this short screw in to the screwdriver, put it into the TPU on carbon, and then just fasten the standoffs as so, and repeat this process twice so you get 2 standoffs on the back. Just like so, you end up with 2 standoffs, 2 screws on the back, and 2 screws on the sides, and the battery tray is already secured. Okay, so the next step is to mount our flight controller, but to do so, we are missing two screws that are going to be the front one, which is this one, and the back one, which is this one. So what we're going to do is that we're going to repeat the process that we did before in terms of grabbing 2 screws and grabbing 2 nuts. And these ones are going to be the mounting for our all-in-one board. So take 1 screw, put it into the driver, go through the bottom, pull all the way up, put a nut, and then start screwing the nut. Okay, let's just leave it over there. Don't do it all the way in. We want to do the other screw to the front. So remember this front hole. Pull the screw all the way in, grab another nut, and repeat the process. Remember not to screw these nuts too tight, because this is plastic and we don't want to strip these nuts. So just a little bit of force, and that's it. And now we have 4 screws into this pattern, which is our same board pattern. So at this point we're ending up with 2 standoffs, 6 screws, short screws, and then 4 nuts. So these are we're going to save these ones because the standoffs, we're going to use them for the front. But right now we're going to mount the flight controller, so the standoffs don't get on the way of the flight controller and we work easily on the build. Okay, now we're going to mount our flight controller. And basically, let me get it here on camera. Basically we get this hardware kit, and this is the flight controller that we get. So this is the BetaFPV all-in-one 20 amp version, Toothpick version 3.0. This one comes with these pads over here. This is like the main layout of the board, and the motors go on the edges of these sides. So basically what you want to do is you're going to mount the board like so, with the XT30 towards the back. This is the back of our drone. So this is going to go like this. But right now what we want to do is to put some rubber grommets that come inside the hardware kit with the flight controller, so it soft mounts the flight controller and the ESC. So basically, let's take one rubber grommet, and I like to put it flat and do some pressure with my hands and my fingers, so it goes to the other side, and start pushing with some tweezers slowly. We don't want to cut the silicone, and then just a little bit of push, and we got one rubber grommet inside. Let's do this step 3 more times. So put it flat with your fingers to the other side, and then insert it with these tweezers super slowly, and then a little turn. Second is on. Help with the tweezers a little bit, and then you have your flight controller with all the rubber grommets. Okay, so right now what we want to do is to mount the flight controller into this pattern. We already put the rubber grommets, and this is a little bit tight into these screws, so we don't want to pop them off. So just align them with the screws and push a little bit gentle so they don't come off. Start pushing gentle with the 4 screws, and there you go. We have the flight controller mounted. We're going to use the 4 nylon nuts from the frame, and we're going to just secure the flight controller with these nuts. So just put it in and start pushing them or screwing them into the flight controller. Okay, so we're good. We already tagged the flight controller to the frame, as you can see, with some nuts over here. And then we're going to work on the motor wires. So I didn't trim them before because I didn't know which is the length that I'm going to use. So we're going to prepare the motors right now. Okay, so right now I'm going to solder the motor wires to these little pads, which are the motor pads of the flight controller. If you look closer, you'll find that we have 3 here, 3 here, 3 here, and 3 here. And those are the ones that we're going to use and enable to solder the motors. These pads are pretty small, so what we just want to do is to put a little bit of solder in them, like tin the pads, and then we're good to go. So let's measure the wires. So put them in the arm and use them straight and give it a little bit of play, and then mark with maybe some tweezers, mark where we want them to be. So in this case I want them to be over there, and I already see that there's a mark on the wire. I'm going to take some wire strippers, and then as I mark them out, I'm going to start cutting them. So the wires for the motors are already cut to length. I'm going to use my wire strippers and just get one wire, and I'm going to peel it off so it exposes the actual wire. I'm going to twist it so wire is cleaner, and I'm going to do the same with all the 3 wires, so all the 3 wires look like this, stripped down, trimmed, and then I'm going to pre-solder them so it's easier to solder to the main board. Okay, as we have the motor wires cut to length, and then we peeled already the silicone, we're going to take our soldering iron. In this case I'm using this one, which is a TS100, goes up to 400 degrees, and we're going to use some solder, which I have here. And for these wires, what I'm going to do right now is just put the soldering iron close to the wire, and then start putting solder into the tip so it just solders the wire, just pre-tinning the wire so it's easier when we solder them to the pads. What I'm going to do now is to solder in these 3 pads, these 3 wires, just straight up. So I'm going to pre-thin a little bit the pads, not too much because these are small pads. I don't want them to be jumpered. So let's start just putting a little bit of solder into them. Okay, the pads are thinned, and as I told you, be super careful not to jumper the pads because these are super small. There's not too much of a gap between them, so be super careful not to jumper them. And we're going to start to solder the wires onto the different pads. Okay, after this step I do 3 things. So first thing is just using a super thin tweezer and just try to go between the gaps so I know that nothing is touching, the pad is not jumpered. Then use some electrical tape. In this case I'm using this black one. And then what I want to do is just cut a little piece, because this is going to strap or secure the wires to the arm. Just put them like in place. I like to hide a little bit the wires into the board like so, and then put the electrical tape from the bottom, which is easier, through all the arm. Like this. And then you end up with electrical tape, wires soldered in, and then you just check that the pads are not jumpered. Final step to be ultra clean with the motor connections. What I like to do is just use a little bit of alcohol with an old toothbrush and just start putting some alcohol into the connection, so all the flux that went with the solder is going to be cleaned off. In order to check that your motor is working properly and your soldering joints are correctly, you just want to spin a little bit your motor, because when wires are touching each other, motor won't spin correctly. So just do it as so, and you check that the motor is properly working, and then you're good to go with another motor. So as we did before with the other motor, remember, put the wires straight and try to go up until the soldering pads, like so, with a little bit of play of the wire or extra wire. Use some tweezers, push the tweezers into the wire so you know that the wire is going to be cut to length. Then you go with some marks onto the wires, and now you're good to go to trim those wires. Okay, you have now trimmed some wires. We have some excess from wires. We're getting it cleaner. As I told you before, some wire strippers, just peel it off a little bit of the tip. Then we have 3 exposed wires. We're going to twist the tip so we can pre-solder them. Put some solder into the wires. So to put some solder into the wires, you're going to put the soldering iron close to the wire and then start pushing the solder into the tip. Do it for 3 of them, and then clean the tip. You just have some pre-thinned wires. What we want to do now is to thin the pads. We're going to put just super small quantity of solder. Okay, so start by taking your tweezers and taking 1 wire, and with the soldering iron put some heat into it so it just solders into the pad. Repeat that 3 times in order to get 3 motor connections. So now we have the second motor. Remember, we're going to put some alcohol first. Second step for the motor wires. Take some electrical tape, cut some, and then arrange the wires, organize them so they are neat. In the center of the arm, I usually do it in the center of the arm. Then just put some tape around it. Okay, so fast forwarding, we already soldered all the 4 motors. We secured the board with some nylon nuts. We also put some tape so wires are secured. We also cleaned these soldering pads, and we checked with a little tweezer that the pads are not jumpered. So with the tweezers or spinning them freely. And now we're going to go to the next step. Okay, so right now what we're going to do is that we're going to connect the radio receiver. So in this case we're going to use a TBS Nano. This one doesn't comes in the box, neither does this. So this is just barely like a mini Model T for this radio receiver, and it's U.F.L connection. So I'm going to connect it, and basically what I want to do, if you're running maybe FrSky or any other nano receivers, you're going to place it here and just basically solder it onto the board, like the wiring diagram I'm leaving you in the screen right now. So in case you have a Crossfire Nano or a FrSky receiver, you are going to put it in the back and then run the wires across the board. So let's get it done right now. So what I'm going to do for the Crossfire Nano is that I'm going to use 4 different wires. We're going to run power, then ground, then RX, and then TX. And it's pretty easy. The path that goes along with the U.F.L, it's going to be ground. Then we're going to have 5 volt, which is the second path. And then we're going to have basically TX and then RX for the other corner. So let's wire those up. Okay, I just soldered the different wires to the RX. I know it's working good. I already cleaned it a little bit. So now I'm going to connect the antenna that I'm gonna use. I'm gonna use this Immortal Mini Immortal T. It's pretty basic U.FL connection, so just plug and play. Then I'm going to run the antenna like so through these little soldering points that I just did, because I want it to be like over there, not move a lot. And basically I'm just going to run the wires downwards the RX, so I can access easily the button which is on the top. To secure everything else in this RX, I'm going to use some heat shrink that comes with it, and I'm going to heat shrink up until this point. So it's basically just the RX heat shrinked. Let's get it done. Okay, so I end up with this receiver connected to this antenna and cables going downwards the RX, so they come up this way, and I'm going to mount it through here, which is the bottom of the quad, the back bottom of the drone, and run the wires towards the board. That's it. So right now I'm going to specify which are the paths I'm going to run the wires to. Then we're going to pre-solder them, pre-solder the wires, and connect just the RX. So we're going to tin the ground, the 5V, T1 and R1. These are the 4 paths that we're going to use with the Crossfire receiver. These paths are pretty close, as I mentioned, with the motors. So we're just going to put a little bit of solder, not too much, in order to tin those paths. Okay, so we just tin the pads. We're going to make the connections with the receiver, starting with the ground wire, which is closer to the nut. We just have to be so careful with it so it doesn't melt the nut. So we just clean and start soldering. Okay, we have wired up the RX with ground, 5V, T1, R1. Right now what we're going to do is that we're going to clean up the solder job, and then we're going to apply some double-sided sticky tape to the receiver so we can secure it, and then continue with the next step. So let's get on it. Great, so what we're going to do now is that I move the wire because it was too short. I move it to another ground, which is the LED ground over here. And what I'm going to do right now is to set up the Unify Pro Nano, so you get your VTX in this nice packaging. And inside you will get pretty much this first bag, which contains an antenna. Could be used for the VTX, and then you get like this board which you use for bigger drones. We're not going to use this, so let's move it aside. Next we get our VTX, this one. It's super tiny, as you can see, and then we get some wires which we are going to use as well. So we're just going to use 4 different wires. We're going to use power, we're going to use ground, smart audio, and then video. So 4 wires, and then the rest of the wires and these pin-headed connectors, we're going to put them away. We're just gonna work on this VTX for now. So I'm going to display again the wiring diagram so you can check how it goes. If you put the VTX with the bottom heading downwards, you will get power input, which is 5 volts up until 13, if I'm not wrong. Then you get ground, which is the second pad going downwards. And then we're going to use this pad, which is basically going to be video, and the last pad, which is going to be smart audio. So we're going to wire those 4. I'm going to run the wires as well through the bottom, so it's going to be maybe cleaner. A little tip is that the pads on the VTX are through hole, so that means that you can connect your wire easier, cleaner, just passing the tip into the hole of the pad and then just soldering it. Okay, so we already wired up the VTX with 4 different wires, which are power, ground, video, and smart audio. And right now we're going to secure the wires, plus we're going to plug in the antenna to this U.FL. The antenna we got is the AXII Micro. In this case I'm going to use a right-hand circle polarized antenna. This one is the Shorty version. So it's pretty tight. We're going to plug in to the U.FL like so, and then we're going to bend it a little, just a little bit like this. Okay, so before I heat shrink it with the antenna, what I'm going to do is that I'm going to pass the antenna through here, because I'm going to use this as the antenna holder. I believe this is meant for it. So right now with this antenna in here, I'm going just to plug it in. Okay, so right now I just put the heat shrink. I just put the wires through here. Wires are going to go like so. Wires are going to go like so, like here, and we're going to wire this then onto the main board. So we're going to finish this up. Antenna is going through this connector. So let's heat shrink this and then start cutting, trimming, soldering these wires. Okay, so we are ending up with this VTX, this antenna, these wires. I'm going just to put a little bit of double-sided tape underneath the VTX. I just wanted to secure it to this TPU board. Okay, as we have it cut, tape, and we just put some pressure, we're just going to flip this little film that comes with the tape in order to reveal the sticky side like this. Then let's flip it and let's put it here secured onto this TPU plate, or print, like this. So we end up with the antenna, VTX, and 4 different wires. Okay, so now we're going to have the rear standoffs, right? We have the RX down there. We have access to this button on the RX, which is going to help us bind this button. We have this immortal antenna. These holes on this TPU are for these standoffs, and this hole in the TPU is going to be for this type of screw that we left here on the back for the board mounting, and then we're going to put pressure, so it's going to go all the way in to the standoffs, and the board is going to be secured as well. Okay, so before I continue with the VTX soldering, I have this antenna here that I want to secure, so it's just perfectly attached. This VTX TPU mount comes with 2 different holes side to side, and I could easily fit 2 of these zip ties. So I'm going to try to zip tie it. Okay, so we are having the Immortal T already secured, right? We also have the XT30 here, and that's perfectly secured. We want to have on this Beta FPV kit for the all-in-one board, we had this metallic nuts. Since we already used all of the nylon nuts, we're going to use this one to secure the TPU mount to the frame with this screw. So just screw it a little bit with your fingers, maybe use some tweezers. Okay, that's pretty much it. You can see it's not going anywhere. Standoffs hold this one as well. The VTX holds the antenna. Immortal T is already secured. So let's start wiring up this video transmitter. You should see on the wiring diagram. So for the ground and battery voltage, we're going to use the front pads to this side, and then we're going to use the same technique we used before. We're just putting up a little bit of force to make it where we want it, just like this. And then we're going to start trimming these wires, stripping them. Then we're going to pre-tin them, and then we're gonna point which are the pads that we're going to use. Again, BVAT and ground for this VTX. So for the video, we're going to use video out, which is 1, 2, 3, 4 pads towards the right of the board. And then we're going to use T2 as the smart audio. So white wire is going to T2 and the yellow one is going to video out. Now let's wire these both connections, starting with the video, which is closer. Great, so as we have the VTX ready with 4 wires, we're going to clean all the connections for the VTX with some alcohol again. Starting with these ones, just a little bit of alcohol. We're going to clean off the flukes that the solder comes with. A little bit of alcohol, and that's it. Okay, so now the last 3 connections, or the last step we're going to take in terms of the main build, is the camera. We're going to use the Caddx Kangaroo. So yeah, let's take it out. There are some parts that comes with it. Starting with the main camera. This is the main camera. It's got a nice lens. It's a new lens that Caddx put into this Kangaroo camera. This one comes with a connector like this, which is female, for the main connection, and then we get this for the board connection. This is going to be important as we do the build. The camera also comes with this controller, this pair of wires which we are going to use. This one is going to be for the camera control, so it's pretty easy. You just plug this into your camera control board, and that's it. And you're going to hook this up if you need to change any settings or anything, and then just unplug. Camera also comes with this adapter, which is nano to micro, but we are not going to use it since the Tiny Trainer has this nice canopy, which is designed for the front standoffs and this actual size of camera, which is nano. There are 3 sizes of screws. We have a short one. Actually, there are 4 sizes of screws. Short one, then we have a little longer one, and then we have the longest And also we have these little ones that, if I'm not wrong, these go on the back of the camera to secure this plate. So we're not going to use those. We're not going to use the shorter ones as well. And we're not going to use the longer ones. We end up with these two that are basically just the middle screws from all of them all. And I forgot to mention that we are going to use this wire. This is basically power, ground, and video. We're going to hook this up to the flight controller, and we can have this option of male and female connector, which is pretty handy in case you need to remove your canopy or something. And this helps you with having a replaceable camera or swappable camera. Super easy to take apart, and that's it. So let's begin with putting the camera into the canopy. So if you check, there are two holes which are going to be for the standoffs on this front mount. So camera is going to be like this. Holes on the canopy are going to be on the top. So that's how we should put the camera in. For putting the camera in, you need to open this a little bit, the TPU. Open the TPU a little bit and just help the camera peek through the TPU. You're going to want to align the holes with the camera holes. And as you do so, put a little bit of pressure so it doesn't move. Take your 1.5 driver, and with this 1.5 driver, put just one screw in, then put the other screw in. So you will end up with this. This is our camera. It's not going anywhere, it's secured. You have these two wires, and these are going to be the ones that you're going to solder. In this case, this, which is female for this. And then we're ready to go with the next step, which is just putting this wire up to here from the back of your board, as in the wiring diagram, and just running the 3 wires towards the front so camera can hook up pretty easy to this wire. So in this case, we're just going to use a little bit of this wire, because this canopy and camera has a long wire, so we just don't need too much of a wire to connect. So cut the wire to length, as so. It's going to be pretty short. We don't need any other than this, and camera is going to plug in right here. We end up with these three wires. We're going to tin the pads on the board, which are going to be pretty basically 5 volts, which this camera uses for powering up. So 5 volts, ground as well, and then video in. Be sure you don't jumper these pads, because it's pretty easy to do so. Let's start with 5 volt ground in. Okay, now we have these 3 wires soldered in to these 3 pads. We're just going to clean it because these are the last soldering joints for this build. So start cleaning them, and just in case I'm going to clean everything else. Okay, so we already have everything wired on and cleaned. I'm just going to give this a little bit of twist. I just don't like wires going too messy, and I'm going to do so with the camera over here. Just a little bit of a twist. This one as well, and then I'm going to mount this here, right? So I'm going to use the standoffs that came with the kit 2 standoffs for the front, and then 2 screws that came with the kit as well. So let's use 1.5mm hex drive. And then I'm seeing that this TPU is not working very good with this beta board because it has a little bit of extra material here in the near the holes of this camera mount. So what I'm going to do is just cut it a little bit, just in order to fit the standoff pretty good, just around this standoff. That's it. So now we're going to push the standoff through the TPU. As we already have these 2 connections, female and male, we're just going to plug it in. Super easy, you can check it out. That's it. We have it ready. We don't need to have just one wire going all the way through this. And as I told you, if we want to remove the camera, it's just unplugging this, and there you go. Okay, so as we have the camera ready, we have it connected. I just want to do a little test. I have a battery here. I'm going to plug it in. I already cleaned everything, already checked everything is good. Nothing is touching or jumping any pads. So let's put some power input. We can see we have lights for our flight controller, we have lights for our VTX, we have lights for our RX. So everything is pretty good. Okay, so I want to stop the build right here because before putting the canopy and the screws, I want to access to the USB from our flight controller and start doing the BetaFlight setup. So it is easier and it is done before everything else. So what you want to do is to go to FPVCrate.com, you want to go to store, and then you want to go to the Tiny Trainer 3-inch limited edition product page. Go to the right and start scrolling down until you find the BetaFlight tune for Tiny Trainer by Adrian Adams. Click over there and you will find these codes, which are basically the codes that we're going to use for the recommended setup for this drone. So to start the walkthrough in BetaFlight, go to the configurator, and then we want to connect our drone to the computer to check how it is before any update or anything. I just see that the board is recognized here in this type of port. I'll click on connect. So we can see on the screen that our board is already recognized by the computer. So what we want to do in this configurator is check which is the firmware we have. Right now it is BetaFlight 4.1.1 and the recommended firmware is 4.2. So we want to update, and before we do, we need to address that the target this flight controller works with is BetaFPV F411. So let's click disconnect. Let's disconnect our drone from the computer and go to update firmware. I want to do this because I want to select here, which is the flight controller we're going to use. In this case is BetaFPV F411. Then we're going to select the firmware version, which is 4.2. We're going to click on not reboot sequence and then full chip erase. These type of boards come with a button that we're going to press before connecting on the computer, so the board enters in the FU mode, which is the mode we need to flash the firmware. So click the button on your flight controller and then connect to the computer again. You need to do the steps in this correct way, so your flight controller is recognized as the FU, and then click load firmware online. As the firmware is loaded, we can check the target is BetaFPV F411 and the version is 4.2. So let's hit on flash firmware. In this process, basically the flight controller is going to update to 4.2 and is erasing the previous version it was using. So we just need to wait a little bit in order to get this process done. Okay, so right now we see that the programming is successful. It means that the flight controller should have the 4.2 version already. So in order to confirm that this is true, we are going to disconnect the USB cable from the computer. We're going to the main menu again, which is this one. Connect again your drone to the computer without pressing the button. And we see that the flight control is already recognized, so click on connect. This is totally normal. It means that this board comes with some custom defaults that we are going to use. So press on apply custom defaults. We see that the drone disconnects again, connects again, and then click on connect. We see that there's a warning, the accelerometer is enabled but it's not calibrated, so hit on close and hit on calibrate accelerometer. Okay, you should see that the accelerometer calibration is finished on the top part, and then we're ready to go. Firmware is BetaFlight 4.2, so we're good, and the target is still the same, BetaFPV F411. So let's go on to ports. First port we need to check is the serial RX. In this case I connected my Crossfire Nano receiver to the UART1. So hit under serial RX. You need to check which UART you use for your specific receiver. Then for UART2 I used the TBS Smart Audio. So I'm going to select under peripherals the VTX Smart Audio, and I see that there's a warning that the VTX table has not been set up correctly. So I will do it as well. So click save and reboot. So we're going to go onto FPVCrate website again. Select all of these commands and hit copy. And then what we want to do is go again to BetaFlight, connect the drone to the computer, go down to the CLI, and then in this write your command, paste what we just copied from FPVCrate website, hit enter, then type save and hit enter again. Which that did is basically it just loaded the information into the flight controller, and when we connect we should have new settings already set up. So I'm going to go to ports, I'm going to confirm that all changes I made are correctly set up. Go to configuration, we're going to use the normal motor direction. This is a Quad X. We're going to use D-Shot 600, and then I personally don't like to use accelerometer. I'm going to select this and put FPVCrate. I'm going to use a serial-based receiver, which is this, but in this case I'm going to use a Crossfire, so I already put the Crossfire here. I'm going to use air mode, OSD and dynamic filter, as well as telemetry and soft serial, so this is already set up. I like to have D-Shot beacon, which is basically motor beeping after my receiver is lost. And I'm going to leave this as it is. So hit save and reboot. Connect again to your drone and your computer. Go down to power and battery. I just leave this as it comes. Go to PID tuning. I believe these are PIDs that are recommended for this tune. Go to rate profile settings. In this case I'm going to put my rates, which I use every time. So basically it's 0.8 in raw, 0.8 in pitch, and 0.8 in yaw for the RC rate. Then in rate I'm going to put 0.67, which is what I use. In raw, then in pitch again, and then in yaw I run it at 0.58. And then for RC Expo, I am going to put up to 0.3 for roll, 0.3 for pitch, and yaw is going to be 0.18. Everything is done. Hit save. I see that the profile is already saved, so go to receiver. In this case, I'm running my radio, which this configuration. I'm going to hit save. Into modes, I'm just going to put auxiliary one. I have my arm switch to the right. I'm going to go to Viper. I'm going to add range, which is auxiliary 3, and then to the right. And then finally, I'm going to use the flip over crash. I'm going to add the range, and I have it set on to auxiliary 2. Go to the right and hit save. So I already set up 3 switches, one for arm, one for Viper, and one for flip over crash. In the motor section, I want to check pretty quick which are my motor's directions. This is something that you should do every time you do a new build. So I'm going to, without the propellers, I'm going to connect my drone with the battery, and I want to put, I'm going to flip the switch. I understand the risk that I don't want to use propellers, so I'm going to start with the motor one, which should be bottom right, and motor is spinning already. You can hear it, but the motor direction is wrong. It's spinning the other way based on the diagram in this screen. So motor should be running clockwise. So this motor is set up wrong. Then I'm going to go to motor 2. It's spinning, so it's the right motor, and it's spinning the right direction. So I'm going to leave it. Then I'm going to go to motor 3. Motor 3 is correctly in terms of spinning direction, and it's the correct motor, so there's no problem there. And then motor 4 is spinning, but the motor is spinning counterclockwise, and it should be spinning clockwise. And then what I want to do is to hit master, and I want all motors to start spinning, just basically to see that they all respond accordingly to the throttle. Okay, so as I remember, motor 1 and motor 4 are not running correctly, so hit here and then go to the OSD. In the OSD, this is basically an NTSC camera, so click on NTSC. What I like to do basically is just hitting battery voltage. I'm going to put the warnings on top, battery voltage down. I like to put crosshairs. Then also I like to go down and select timer 2, which is the flight time. I'm going to set it to the right. And then finally I'm going to go to throttle position. I'm going to set it to the left. We will check just that the units are in metric. Timers, I don't do this, I don't do this. And warnings, I want to do all the warnings. And for the post-flight statistics, I want to check. I'm not using any black box, so I'm going to uncheck this. I want to see my voltage in the end of the battery. I want to see the timer too. I don't need any speed maximum, and I'm going to hit save. Okay, so as we have the OSD set up, we're going to go down to video transmitter, and here we're going to basically want to add the VTX table. So let's go back to internet and let's search for VTX table. Let's click on this GitHub website, and then we see we're going to scroll down until we find TBS, currently only applicable to latest TBS models, so like Evo or Pro 32. So we're going to click here, Smart Audio 2.1 USA, save as, and we want to save it as JSON. I'm going to save it on my desktop, so click save, and I'm going to go to my desktop again, so desktop, and I want to make sure that this is
JSON and not txt. So I'm going to erase .txt. I'm going to use JSON. I have it here. So let's go back to BetaFlight, and in the video transmitter tab, go to load from file, and this PTX Smart Audio 2.1 JSON should come up. Hit open. Okay, so VTX config file loaded. So we have it ready. Here is what we have. So click save. So basically I want to select Raceband 1, which is what I currently use, and I'm going to select 400 milliwatts. I want to run it this way, no PID mode, and then hit save again. Okay, so it's saved. Okay, so we finished basically every step for the BetaFlight configuration. I'm gonna hit disconnect because right now I want to go to BLHeli to change the motor direction in motor 1 and motor 4. So come here to BLHeli S. If you don't have it, you need to download it. It's free. So connect your battery to your drone again. And then here we can see that the flight controller is already recognized. So hit on connect and then hit on read setup. So it's reading basically our ESC. In here, ESC number 1, we have it motor direction normal. I want to hit reversed. I want to go to ESC 4 and hit reversed as well. In this tab I want to hit right setup because I made some changes. And as I finished, hit on read setup because I want to see if it saved. So we can see it's reversed on the ESC1, ESC2 and ESC3 are normal, and then ESC4 is reversed as well. So hit on disconnect. It should reboot our flight controller. Quit and then go again to BetaFlight because I want to check motor directions again. Hit on connect, and then you want to go to motors tab, hit on the I understand the risk, and then check motor 1, which is bottom right. Okay, now it's running clockwise. And then motor 4 is clockwise as well. So we're ready in terms of motor direction, motor order, and everything else. So click again, I understand the risk, disconnect, and we're ready to finish the canopy and the screws.
So for the canopy, we have this canopy and we have this fin. Fin goes on top. When we do this, and canopy goes on top of everything. Just start putting it, checking everything is okay, aligning holes from the back standoffs, front standoffs as well. We end up with 4 different screws that came with the kit. These screws are the same length. We're going to use these screws to secure the canopy as well. So just start by screwing into the standoffs. Okay, we're good in terms of canopy. That's it. Now we see that the arms have still like a play in here. So what we're going to do right now is the kit comes with different zip ties. We have 4 laying around, so we're going to put them in. I like every time to put the cap of the zip tie inwards the drone, like this. Put a little bit of pressure with your fingers, and the canopy has this lip so the zip tie won't go anywhere, and repeat this step. Okay, zip ties are cut, and there you have your tiny trainer. Let's remove this cap, then power it on. and you see how it looks. Motors should spin freely as well. That's it. For the final step, because we already did the whole build, we're just going to use the props that comes with the kit. I normally run props in. These props are a little bit tight on the hub. They are designed like so. So I just put a little bit of pressure. Prop goes in. Do as well for the second motor. You need a little bit of pressure on these props. Okay, so now you have your tiny trainer. Props correctly put it on, and that's how it should look. So it's pretty much a 3-inch 3S drone. For the battery, this is going to be a little bit of a tight fit. That's how it is designed. So just help yourself with these different inserts to put the battery in, and then start sliding. That's it. That's how it should go. And there's your tiny trainer.